let's find how to find Ax is equal to B kind of a solution. Now, as we know that A is our equation, this A is given by X is equal to B. A is this matrix 3 by 4 and X is U, V, W, Y and B is, let's say B is given as 1, 5, 5. Then to solve this one, so as usual with the same thing, we can't solve this equation because it has 3 equations with 4 unknowns and this becomes impossible to solve. So in order to solve this one, we have to convert it into the Ux is equal to C form. So and even at last we have to convert it into Rx is equal to D form. So as B is not equal to 0, the solution will not be same as Ax is equal to 0 in finding the null spaces and even some other solutions. So the values of B1, B2 and B3, because we have 3 rows, we are given with as shown here. Now to solve this one, we have to go for reducing this one by using the row operations. As we know, in the last problem we have converted this A to U form by doing the following row operations. So when we perform these operations on A, as already we know what are those operations, so just we'll write U and we'll replicate those operations. So R1 is kept as R1 in the first step, but R2, the second row is nothing but, the second row obtained is nothing but second row minus 2 times the first row. So when we do that operation, second row here obtained is the existing second row minus 2 times the first row. So when we perform this operation, we are getting this, and R3, this R3 is equal to, again, in order to make this one as a 0, so we were performing the addition. R3 and R1 were added. So we were getting that intermediate form as we know, and to make those as 0, again in the last step we performed R3 as R3 minus 2R2 to make these all rows of the third row as 0. Then when we perform, as B is not 0, these whatever the operations we perform on the left side, they have to be performed on the right side. So just like we'll be having this, in order to get U, the operations performed would be like, we have not changed the first row, but second row is nothing but the second row which was there already minus 2 times the first one, and this, in order to make this one 0, whatever the operations we carried out on the third row, where B3 minus 2B2 plus 5B1, all those summed together will give this equation. Now we need to go for solving this one. Even by writing them as column spaces, we won't be able to solve it. So what these column operations or what these column spaces give us the understanding. So when we see the equations of these columns clearly, so we get to know that the first column is an independent column and the third column is also an independent column. Independent means there is no dependency, or it has not been obtained by the linear combinations of the rest of the columns. Here the third row, as we can see, this third row is nothing but when we multiply this third column, when we multiply this first column by 3, we'll be getting this third column. Means the second column is dependent on the first one, and similarly this fourth column is nothing but, so 3 minus 1 is 2, 9 minus 2 is 7, means by subtracting the first column from the third, we'll be getting this fourth column. Means the second and fourth one are dependent, wherein the first and third are independent. So we'll be getting the pivot elements in the dependent in the independent columns only. The dependent columns will not have pivot elements, or they are not referred as pivot columns. They are the free variable columns. And when we think of the plane and this linear algebraic method, so the column space C of A, the column space C of A can be described in two different ways. On the one hand, it is the plane generated by columns 1 and 3, because here these two are independent, and the other columns lie in that plane, because as the second one is the multiple of the first, and even the fourth one is generated by the linear combinations of first and third. So these rest two, the second and fourth, are obtained by these two. So the plane of this columns of this matrix is generated by using first and third columns only. So we go for solving the understanding of like how Ax is equal to B is to be solved. Then the third, as we saw in the last thing, this third one, b3 minus 2b2 plus 5b1 is equal to 0. Now this Ax is equal to B becomes solvable if and only if we need to take the values like b3, b2 and b1. When we substitute these values of b1, b2 and b3, it should result into 0. Then only the equation becomes solvable for those values of b, otherwise it is impossible to solve. So first we need to check the solvability of the equation. And we know that the values of b1, b2 and b3 are just 1, 5, 5. They are 1, 5, 5. When we substitute those values, this x is equal to b is this one, 1, 5, 5. So when we substitute this b1, b2 and b3 values in this equation, so b1 is 1, b2 is 5 and b3 is 5. So it is 5 minus 10 plus 5, which gives 0. So as we get this last equation is equal to 0, we say that it is solvable. So if this third condition makes it as 0, if this equation becomes equal to 0, then only x is equal to b becomes solvable. Otherwise, no. Now, the values of Ax, when we obtain Ux is equal to C, the operations were performed even on B's. So B1 is 1, as we know. B1 is 1 and B2 minus 2 B1. B2 is 5 and minus 2 B1 is 2. So when we subtract 5 minus 2, we'll get 3, and similarly this would be 0. So in that Ux is equal to C, we need to get this column, and which is the operated column. To obtain C, as we were performing the operations, this equation, this matrix will turn as 1, 3, 0, because it was B1, B2 minus 2 B1 and all. When they are substituted, we are getting Ux is equal to C, and C is this matrix. Now we go for solving these equations. So let's write the solutions of this. It would be 1u plus 3v plus 3w plus 2y is equal to 0, as we can open this equation. When we go for solving this one, this will be u plus 3v. So u plus 3v plus 3w plus 2y is equal to 1 is our first equation, and second equation is 3w, because first is u, v, now third is w. So 3w plus 3y is equal to 3. We need to write. So Let's solve the second equation so that we'll get the value of w. So from this equation, w is given by, w is obtained as, it is 3 minus 3y as the value of 3w. So w is equal to 1 minus y. Now let's write the equation for u. U is equal to, take this all on the right side. So it becomes minus 3v minus 3w it would be. Let's substitute the value of w, which is 1 minus y. Then minus 2y. This is plus 1 as it is. When we solve this, we are getting it as minus 3u minus 3v minus 3 plus 3y minus 2y plus 1. When we solve this all, we are getting minus 2 minus 3v plus y. Now, this will be, let's write this one by using x is equal to u, v, w and y. And we know that x is the sum of particular and the null space solutions or special solutions. And let's elaborate what is the special solution and what is a particular solution. So let's write x is equal to u, v, w and y, and the value of u from this is, the value of u is, just we are writing it as minus 2 minus 3v plus 5 as it is. The value of v will be taken as it is. W is nothing but 1 minus y and y will be y only. So when we write these values, we'll be getting x is equal to u, v, w and y. These values. So let's go for understanding this one. So u is value, v and w value when they are substituted, and v and y. Now these are our independent values, independent pivot values, variables, and these are our dependent variables. Now let's write in this form. So it would be a summation. Now we can see there is v and there is v in our equations and y is there. So let's write v and y. We have to write it for free variables, not for our dependent or pivot variables. So if we go for writing this way, now it would be with v, that is minus 3. So let's write minus 3 here. And with this y, that is 1. So in the first row. And minus 3v and y are being written. But what about this minus 2? So this minus 2, we need to write it here. So this is minus 2. Now this v has to be written as 1 here, whereas in this row, in this column, it would be 0, and here also it would be a 0. Then the third one, 1 minus y. We know that this y is there, it is to be written as minus 1, but wherein this v is not there in our equation, so let's write it as 0, and 1 is there except that, so let's write 1. So the equations would be in this way. Now last one is y. So we need to write 1 over here, and this would be 0, and even this would be 0. Now as we can compare from the last, as we have that last example, so it is minus 3, 1, 0, 0 and 1, 0, minus 1, 1 are nothing but the null spaces of RA as we have solved them, and we have that solution. So these are the null spaces, and except those null spaces, this is minus 3, 1, 0, 0 and this is 1, 1, 0, minus 1, 1. So these are the null spaces. These two are null spaces and these two are the null ones. This is x of n, we can write null space, and the rest one means this side, this one. So this is nothing but xp. It is referred as xp. xp is nothing but a particular solution. So now x is x can be written as it is x complete, and this x complete, let's write it as x complete. This x complete is the sum of two x's. One is xp, that is the special solution, plus the xp, that is a particular solution, and the special solution. So x complete is the sum of xp plus xn, where xn is the spatial solution or null space and xp is the particular solution. Then after learning this, we may have then why should, already we have obtained the solution and these values are fine. xp and xn we have obtained. Then the next thing is how, after reaching Rx is equal to 0, let's run. What is this? What is the need of this? So the solutions are in this way. So Ax, what is the methodology in solving this? So reduce Ax is equal to b to Ux is equal to c form so that we can solve it. Then with free variables as a 0, find particular solution. So we need to find the particular solution by considering free variables as a zeros. So we'll see that one. Find the special solution to Ax is equal to 0, and the x complete would be the sum of xp plus xn. Now let's learn this. What is this? By considering, so with free variables is equal to 0, find the particular solution by considering free variables as 0. So how can we obtain the particular solution by considering the free variables as 0? Because just now we have obtained the complete solution. Now, and even we need to understand what is that Rx is equal to D, the heading we were learning. So what is this Rx is equal to D? That is going to tell us. So what is the importance of that? Now as we can see, the last equations, the equations are these, and when we solve those, this is the thing that we have obtained. And this one is referred as a particular solution, and this is nothing but the special solution or null. X complete is equal to this. Now what is the need of Rx is equal to D? Rx is equal to D. As we know, Rx, R is nothing but the U itself, but in that U, let's learn it here. In that U, the values of the pivot elements have to go 1, and the elements in that particular column where the pivot column is there, so the elements in the pivot column have to be only pivot should be a non-zero element and it should be unity, and the rest other values have to be 0. And to get those, we have to do the following operations. Now here there is a 3. We have to eliminate and we have to make it as 1, because this is a pivot element and this is another pivot element. And to make this one as 1, we have to divide this second row by 3. So when we divide the second row by 3, then the things would be here in this way. This goes 1, 1, and this is 3, 1, 3, 0. Ux is equal to c, and c was equal to 1, 3, 0, we know. So when we divide it, 3 by 3 goes 1. So this is nothing but 1. And as it is a pivot element, we should not have the value here as non-zero. So to make it as 0, we have to perform the operation. So this R1 has to be, the new R1 has to be the present R1 minus 3 R2, because we have to cancel this 3 to 0. We have to make this 3 as a 0. So to get that, so we perform R1 is equal to R1 minus 3 R2. Means this R2 remains as it is, R3 remains as it is, but this R1 is nothing but, so R1 minus 3 R2. R1 is 1 for the first element, but 3 R2, this element is 0, so it remains as it is. And for this also, it is 3 minus 3r2. Again, this r2 is a 0, so we'll get this as it is. Now for this third one, it is r1. Right now it is 3. 3 minus, so we have taken 3r2. So the value of r2 is 1 multiplied by 3. When we subtract 3 minus 3, we get 0. And similarly, for this, it is 2 minus 3 into this element is 1. So it would be minus 1. So we get this one. And the same operation has to be performed on the first element of this C. So when we perform this operation, it is nothing but this already existing element, which is 1, 1 minus, and this is also 1, we know it is 3 divided by 3. So 1 minus 3 into 1. 1 minus 3 into this 1. So minus 2 it would be. So the next column of this C is going to be minus 2, 1, 0. And now we can see this U is in the form of R, because this is the pivot element with only unity as a non-zero element at its pivot place, and same here. And these two we don't have to worry because they are not the pivot columns. Then when we go for solving this one, and this is no more C, now let's refer it as D. And as we can see, this contains minus 2, 1 and 0. And in learning this, we can go for writing it as 1u plus 3v minus y is equal to minus 2 and all. We can go for solving those equations, or straight away we can come for the conclusion that here we know that u and y are the free variables, and for the free variables we have to consider the values as 0. So we need to consider the values as 0 for the pivot variables, and only u and w values are to be taken. So here this is u, and the second one has to be considered as w, because v and y are not the pivot elements, pivot columns. So let's leave those v and y. So the values of u, the value of u is considered to be minus 2, and the next pivot element after u is w, and for this w the value is considered to be as 1. Then when we write those in the column, it becomes the same kind of a vector. It would be minus 2 at the uth place, at the v place it is 0, at the w place it is 1, and at the yth place it would be 0. So we'll get the spatial vector straight away from this solutions. So this is the use of that Rx is equal to D, and D is nothing but a column vector which is having only the values, the particular solutions of pivot variables in a order. So u, v, w, y. If u and v were the pivot elements, then these could have been the values of u and v. But now here u and w are the pivot elements, so its value is u and its value is, it is, the u's value is this and w's value is this. So this gives us the particular solution. The same we can learn. Now even instead of solving ux is equal to c, we can go for solving Rx is equal to D. We can obtain the particular solution, and then we can go for the special solutions. So in general we can say that Ax is equal to B, or A vector, A matrix can be solved by, to obtain its complete solutions, we need to find the particular solution by using Ax is equal to B and converting it to ux is equal to c form and Rx is equal to D if required. And we have to even go for a special solution Ax is equal to 0 to obtain the null space. So the combination of null space and particular solution is nothing but the complete solution of our equation. Now let's quickly learn how about the second problem. Let's have a glance on the second problem. So before that, okay, let's see that one in the next video. So let's stop it here.